When people talk about hardware rendering, they usually mean real-time display of geometry and textures for interactive use. In Maya, the hardware renderer is used to create bitmap images. You can access the hardware renderer if you just go under Window, Rendering Editors, Render Globals, and just change the render using to Maya hardware. Now, basically the hardware renderer uses graphics card to compute the images instead of using the computer CPU like a software render would do. And this method is actually much faster than the traditional sort of software rendering that we have. Now, before the hardware render option, a hardware render was performed using the hardware render buffer. And this was used mostly to output either hardware rendered particles or to create low quality previews of animations. Now, both these methods do use the speed of the graphics card to create the images, but the difference is in the quality. The hardware renderer delivers a much better quality than the hardware render buffer. Features that you can hardware render include poly and NURB surfaces, transparencies. You can use point, directional, spot, and ambient lights. You can use a number of, or an unlimited number of lights. You can do light linking, shadows, motion blur, alpha, and Z depth output. The other really nice thing about the hardware renderer is it allows you to output images in batch mode. So what that means is that we can now do a hardware render in the background, which was not possible with the hardware render buffer. So let's look at some of the attributes that are in the Maya hardware render globals. So as you can see, we have a common tab. So this is where you set your resolution, your image format, that kind of thing. And if we just click on the Maya hardware tab, under quality, we have a number of preset settings that you can choose from. And just moving down the line here, enable edge anti-aliasing. Now, if this is on, you can change the number of samples. So for instance, 9 samples, you can go right down to 36 samples. The more samples you choose, the longer this is going to take to render. I do want to point out, though, that if this is turned off, you will only be taking 1 sample. Even though it says 36, you are actually only taking 1 sample. Okay? So moving down the line, transparency sorting. This is done prior to the render. So this is how the render decides how it's going to sort the transparent depths. Now there's a per object, which is usually good for not too complex transparent objects. And then there's per polygon, which is much more complex. Now in terms of render time, the per object does not take as long to render as the per polygon. Color texture resolution. Now, if the hardware renderer can't evaluate a certain shading network, it will actually bake it. Now, what this option does is it specifies the size of that baked image. So 512 by 512 will be the baked image size for a network that can't be evaluated by the hardware renderer. And same sort of thing for the bump texture resolution. If it can't evaluate a certain network with a bump, then it will actually bake that network. And this is going to be the size or the dimensions of that bump. Now, just a general rule of thumb is it's always a good idea to keep the bump a little bit higher in terms of resolution than the color. Now, just under render options, enable render layers. Culling, you can do culling on a per object or double-sided or single-sided. And then the other really nice thing you can do is you can motion blur. So turn on enable motion blur if you want to hardware render something motion blurred. And then motion blur by frame. As we spoke earlier in the special effects chapter, motion blur is really, it's achieved by looking at specific points in time and then blending the results to get that blur. Now the blur by frame adjusts that. So usually a higher value here will give you more blur. And then the number of samples. Basically the higher the number, or excuse me, the number of exposures, the higher the number of exposures, the more smooth that blur is going to appear. So why don't we look at a file here. What I'm going to do is I'm actually just going to do a little bit of a comparison between the Maya software render and the Maya hardware render, just so that you can see the difference. So I'm just going to go back to the software render, and just under the Maya software tab, I'm actually going to turn on motion blur. Okay, so we'll just turn on 2D motion blur, and I'm just going to turn up the samples, or excuse me, the blur by frame to 3, and let's do a render. Okay, and you can see the timeline, where it's sampling at 15.6. And so we'll keep that image. And now let's go to the hardware render. So I'm just going to change the render using to my hardware. Okay, and we'll just go to the My Hardware tab. So Enable Motion Blur is on. That's great. So let's change that motion blur by frame to 3. And let's do a render. Okay, so you can see that was very fast. Not really the best motion blur. So probably what we're going to do is we're going to need to increase the number of exposures here. So let's turn up the exposures to something like 10. Okay, and so that actually looks like a pretty good result. And it's not too different than the software render, but it did render a lot quicker.